Good afternoon, everyone. We're going to get started. Welcome to today's webinar on air quality filtration technologies and sustainable building as part of our educational webinar series from AHRI. My name is Nabil Shaheen, and I will be the moderator for today's session. We're thrilled to have all of you with us as we explore and learn about indoor air quality from an HVAC perspective, and how it affects HVAC efficiency. And we're going to be also demonstrating like a practical example. So throughout the webinar, we will learn about the latest advancement in air filtration technologies, discuss best practices for enhancing indoor air quality, and its implications on sustainable building designs. We will have time for asking questions at the end and sharing your thoughts. So you can type your questions in the Q&A button on the bottom. And so we can have a session at the end for about 10 minutes. Okay, let me switch to the next slide. All right, so today we have two gentlemen with us, and I'm going to introduce our first speaker, Dr. Iyad Al-Attar. He's a mechanical engineer, air quality consultant, and a visiting academic fellow at Cranfield University. He's also the strategic director and advisory board member of Waterloo Filtration Institute. In 2020, he advocates for global government roles and in air quality monitoring and enhancement, and has published extensively on filter design and performance. Dr. Iyad holds a degree from the University of Toronto, Kuwait University, and Loughborough University, and he's pursuing his MSc at the University of Oxford, Sustainable Urban Development for Air Quality. With that, I will stop sharing my screen and turn my screen to, let Dr. Iyad start his presentation. Dr. Iyad?
Thank you, Mr. Nabil, and I appreciate the invitation to share my thoughts today with the AHRI audience. I hope you can see my screen, and if you do, please let me know so we can start. Can you see my screen?
Yeah,
can you see my screen? Okay. Thank you so much. Good afternoon, good morning, good evening to all our audience, wherever you are. Air quality has come into the spotlight in late 2019. Our cities and buildings have been invaded by the coronavirus. And as we may all know, urbanization has been increasing since the early 1900s. Believe it or not, in the 1800s, only 5% of us lived in urbanized area. Today, we're 54% urbanized and expected to reach almost 70% by 2050. We're going to be adding 2.5 billion people to the urban environment by that time, which is 2050. And that's going to require cities and buildings that are sustainable. Cities are the bedrock of any sustainable urban development. It's where innovation happens, where economic growth, education for people to get a social standing, and basically where 80% of economic activities take place. But at the same time,
Iyad, sorry for the interruption.
Yes.
I'm not sure if it's just me. I don't see the presentation on the screen.
Okay.
Can you make sure you're sharing? Okay.
Is it shared now?
Now I can see it. Thank you. Sorry.
Okay,
yeah. Continue.
Yeah, so thank you. So we're going to be adding 2.5 billion people to the urban environment. That means we're going to require a lot of efficient processes. But as I said, 70% of energy gets used in cities and buildings. And that's, today we have two happenings. One is we'll have new cities be constructed and existing cities being remade. Research has shown that no country has ever been able to become rich without urbanizing. The scale, speed, and scope of urbanization is critical so that we can have a low carbon way to live, and eventually cities and buildings will help us reduce waste in terms of land, energy, material, resources, and even human potential. Cities also, according to research, will help us go from poverty to prosperity and promote models of dependence, of development rather than dependence. But all the trouble we're causing is just due to an 2% of occupying the Earth's surface. So cities represent only 2% of that, given all the environmental issues we're facing today. So we learned during the pandemic that first, we need clean air. Two, we expect HVAC systems to deliver that sustainably and hopefully fairly to all inhabitants, irrespective of their socioeconomic status. So we all know that cities compete for people, compete for investments and prosperity, and people compete for clean air. So how do we ensure that we got this delivery of clean air to 8 billion people? As I said, we are running amok when it comes to environmental behaviors. Our footprint is on the rise, and that's going to further challenge the HVAC systems and the installed air filtration systems we have. Whether you are in an urban area or you are in rural areas, the pie of pollutants that you are exposed to, whether the respiratory system of the inhabitants or the HVAC systems installed, will be further challenged by various sources of pollution. Of course, in construction, we have different sorts of challenges. We have dust that may be containing cement, silica dust, and other particles that can impact the health of inhabitants or human occupants indoors. Of course, we've got our old friend, sandstorms, especially in the Arabian Peninsula and other regions where this occurrence is frequent, and that basically causes a deviation in the air filter performance, the deviation from this air filter test report that is accompanying the manufactured or the manufacturing recommendation of filter performance. Health impacts, and I'm sure you've heard a lot about this, but if you dig deep enough, it's not just the respiratory system that can be impacted. PM1, that is 1 micron and below, can actually leave the respiratory system and basically penetrate to the bloodstream and eventually impacting other organs in the body. For respiratory systems, when we have irritants basically causing wheezing, that's because, as you can see here, the cross-section of the respiratory system becomes smaller, and eventually some medication like inhalers, which some of us take, will help put this back to the cross-section required to be able to inhale and exhale. The coronavirus has really made us think beyond particle capture and to address microorganisms and whether or not our filtration system and HVAC systems are equipped and capable of being a defense line to confront the virus transmission. So when you look at global contamination or global air pollution, we have two things that kind of coincide. First thing is the hot climates are fairly or not the same climates that suffer from high air pollution, which means more emphasis placed on air conditioning and air filtration to be able to bring clean air to the indoor spaces. Clean air will have probably more than 5 elements, but today I'm just bringing 5 elements to your attention, which is HVAC equipment, air quality, building emissions, energy efficiency, and most importantly, in my judgment, is urban planning. Urban planning means you place air quality as a pillar in the forefront, as a major priority in the sustainable urban development, not as an afterthought when pandemics take place. So what do we really look at in terms of clean air? I mean, how do you really gauge clean air in terms of definition? How can I gauge expectations so that you can say, I am actually inhaling clean air? Very difficult to do so when you're running or operating HVAC systems with failing filters and contaminated coils. It's also very difficult to have a clear definition because the application can bring sensitivity to that definition. So whether we are in schools where clean air research has proven that it will affect the cognitive performance of students, their health, alertness, attention, and also their comfort. Another dimension of this is the fact that we have emissions from school buses, and whether or not this has been considered in the design, or whether there's a special parking area so that we don't challenge our own facilities with our own emission. How much value you put on air quality for your kids, how much you're willing to pay, is certainly a different conversation that we can have in the Q&A session. For hospitals, there are possibly two prescriptions that we need to get when we get sick. One is in the actual medication, and probably another filtration prescription that will deal with all the pollutant types, concentrations, size distributions, so that we render this air fit to be inhaled. Of course, that's subjective because it's application sensitive, it's geographic location sensitive, so a lot of parameters play a role in this. What also plays a role in a hospital environment, which is designed to be a healing space, not just a housing space, as it was designed or aimed for, in the late 1800s. We look at not just thermal control, but we need to control infection. We need to save energy. We need to look at the health and safety, not just of patients, but doctors, staff, and visitors, and of course, the operation and maintenance. Another dimension that's always overlooked is what could actually be held in these beds. And this is some of the dust that was recovered. Of course, if you go into a microscope, you'll probably find dust mites and dust mites droppings and eggs in there. So this is another critical aspect of hospital air quality that is barely looked at. Again, airports, it was highlighted during the pandemic. What pollutants are we looking for? Aircraft engine emissions, are they able to be filtered before they come in? Is it considered when we do our appropriate air selection? What is the value on the travel experience? How do I spend time in an airport? And again, research has brought this topic to our attention. The pandemic has actually brought more emphasis into it. 4 aspects we can look at very quickly. One is filtration, maintenance, HVAC equipment, and air quality. And again, filtration has been really put on the back burner for years. It has been overlooked, ignored, and even in times where it was addressed, it was unfortunately misunderstood. So filtration depends on the particle size distribution. The concentration basically happens in stages because the dominant mechanism may differ depending on the particle size. And this is certainly will affect the number of stages required, for example, in a hospital to be able to bring in the air quality required. This is an experiment that I've done earlier on. You can see 4 stages of filtration. Last 2 stages is F8 and H13. And in the absence of an F8, You can see the HEPA filter here is loaded with a lot more particles, a lot more concentration compared to the other HEPA filter that was protected by an F8. So it had a good pre-filtration. What we look for is not more filtration. What we look for is sustainable filter performance. And this is basically, you can see here, this is a HEPA filter. And hardly ever you'll see dust cake formation forming on a HEPA filter. That definitely means that there is a malfunction somewhere in the pre-filtration stages preceding this filter. So let's take another look and say, yes, we all seek filtration. It's a low-hanging fruit in terms of technologies. But unfortunately, filters fail. They leak, they balloon, they deform, they deflect, they disintegrate. And in fact, they actually corrode. So what do we do to avoid this? The secret here is appropriate air filtration selection, because filtration mistakes can be very expensive, whether losing a loved one or contaminating an HVAC system. And to be able to bring that HVAC system to the design point after it's been contaminated, it's rather very, very difficult. Then brings in maintenance, which is also an important topic. And two things here is how much value, again, you put in on the maintenance crew. Are they part of your air quality successful equation? Do you provide them with the tools, conditions, incentives to be able to sustain this harsh job and the difficult climate conditions that they have to deal with? I'm just comparing here with, how would a air quality engineer would basically be equipped with the tools, the required outfit. And in other countries, you can see here, he's basically just equipped with a screwdriver. Water accumulation, inappropriate filter installation, inappropriate orientation of installation. As you can see here, no protection whatsoever. The other aspect here is the maintenance, always recommended to be from the upstream, not the downstream, as you can see here, because this is a wet area and can actually foster contamination. Could be very, very risky in terms of health for the technicians themselves. Now, everybody during the pandemic was asking for more flow rates of the HVAC systems and more ventilation rates. My question to the audience is, we need more of a system that is functioning very well, from a healthy system, not from a contaminated system and not from a malfunctioning system. And what I'm showing you here is contaminated coils, which my colleague, Dr. Engineer Iyad, will address in his presentation. And you can see here, very difficult to be able to bring this coil to the, let's say, design condition or original condition so that your heat transfer mechanism is optimized. It gets very difficult because sometimes you're washing dust into and water into the filter or into the coil, rather, not out of the coil. More challenging are the thermal wheels, and you can see here very fine spaces, and you can see the water and the dust particles trapped within the system. Of course, excessive washing can cause further contamination. And then the after fact of having a malfunctioned system, contaminated systems where dust and microorganisms and mold settling everywhere. How much would you have to invest to be able to bring this system back to its healthy original condition? And again, where does the dust or the particles or the contaminants have to land? Of course, we would like them to land on the filters so that we have a line of defense that will protect the human occupants. Again, before we make that call to be able to maintain the system, we need to look at or we need to consider our HVAC equipment. And filters are encapsulated in these equipment, so we need to make sure we tackle the issue. And if you have an odor issue, for example, in your car, you'll probably have to check your trunk, check the back of your car. Possibly there's a dead fish. So we look at removing the source. or repairing where the source or removing it so that its contribution in terms of pollution does not become an issue. We can isolate it. We can have a pressure differential so that it can stop it from infiltrating through the building. We can minimize the exposure time, and eventually we can reduce the concentration of pollutants by ventilation. As I said, the aim is sustainable air filter performance and not just more filtration and higher efficiency. As you can see here, even if you install high efficiency filters, but for example, your drain trap is clogged or too short or not maintained very well, eventually you'll have issues. So we simply look for fixing things, and we look at our HVAC system. But before we do that, we need to look beyond the thermal comfort of buildings and beyond particle capture. Can go nuts chasing every little particle. That will cost us a lot in terms of filtration. Installing air filters is energy intensive, but we also need to look at other parameters. CO2, relative humidity, NOx, SOx emission, other gases that may impact our health. How about human occupancy? And why not distinguish the issues, whether it's a ventilation issue or a filtration issue, or possibly sometimes a combination of both? Do we have the right ventilation rates? And does that work when I have close proximity of human occupants like schools, sometimes airports, and so on? So air quality is not just a straightforward answer you get. This is why air quality monitoring is of a paramount importance when it comes to clean air. As you can see here, people arrive to work, VOCs increase, carbon dioxide increase, and then as shown here, the human occupancy with their emission makes this workplace unfit to occupy. It becomes fit to occupy when the human occupancy decreases, and eventually people leave and go home. With these kind of profiles, whether it's weekdays and then weekends and weekdays, artificial intelligence, Internet of Things, and big data can actually bring about a lot of interesting decisions to be made on the spot, so the system can respond to indoor air quality variation, whether it's a pollutant that is increasing or whether it's a human occupant that's maybe causing an increase in carbon dioxide or VOCs emission. So these sorts of technologies available today, I don't think they were available 50 years ago. So we have a lot of tools to make things happen. Also, we expect the government to play a role, not just in locking down cities when things get really, really bad and the virus transmission becomes, beyond control. But this can, let's say, start with legislating air quality policies that can bind the facility management, building owners, to bring air quality as a pillar, just like you have electricity and just like you have water in your tap, and you can flush a toilet and live in that building or work in it. It has to be legally binding as well. But there is nothing wrong with having a stimulus plan where people who abide by the rules and bring air quality can be rewarded through incentives, interest-free loans, tax rebates, and returns. The objective here is we do not want our cities to become catalysts for virus transmission. Unfortunately, this is what happened during the pandemic, and today we need to make sure we have the appropriate realignments. So what realignments are we looking for? Do we really need new technologies? Do we need to tweak standards? Do we need more tools and conditions? Or maybe we need also new mindsets to embrace the entire way we approach air filtration, air quality, clean air, HVAC systems, the built environment, and if you zoom out, how you design cities, how you design buildings. What is sustainable urban development going to mean to you when you design or bring about these sort of topics? On the top, an explicit priority is air quality. I suggest three things that needs to be engineered. One is understanding the physical and chemical characterization of the outdoor air pollutants you want to bring, you want to render to bring the air indoors. You need to have an infrastructure of indoor air quality and outdoor air quality monitoring so that you can have mechanisms that will help you determine how to respond to variations in indoor air quality relative to the geographic location and the outdoor pollutants that will challenge your system. And third is basically the HVAC equipment selection that needs to be adaptive and responsive. And most importantly, to think of filtration not only as a technology, but as a system, as I said, so it can respond to any variation in indoor air quality. You can do that if you have the appropriate tools, conditions. There are too many moving targets when we look at achieving air quality because it's different and varies when you have different application. But it's also very difficult to enhance air quality when you have a broken ladder of air quality and when the air pollution concentrations are on the rise. So what I think, in my judgment, we need to look at, given that the achievement of air quality is more of a moving targets kind of thing, is to equip ourselves with knowledge. We need efficient processes, not only to be able to respond quicker and more more responsive, but also we need to make sure we lower our emissions so we don't have to filter so much. Right now, we're polluting so much, and we're just basically going back and installing extensive filtration to be able to capture every single pollutant that we are trying to, or we've emitted. This is not really possible because it's very difficult to have a filter stage for all the gases and particulates that challenge our indoor air quality. Tools, conditions are very important, so this indoor air quality engineer can provide a great job. Now, just to begin to wrap up, how much value you put in air quality, and how much would you be willing to pay for clean air? All I need to ask you is how much you're spending on coffee per year, how much you're spending on smartphones, hard to reach destination when you go on vacation, home theater, cars, double garage in your house, kitchen, and interior design. If you look at that, you'll probably look at $1 or $2 per day to enhance your indoor air quality at home. I think what I invite you to do today is to rethink and reimagine how we look at the entire air quality in building envelopes and buildings and in the cities. And who's right? I mean, those two traffic lights tell you the same information, and it's okay to look at new answers for different questions. And I highly recommend that you read that book. It says Being Wrong, and it will really bring about a lot of ideas in terms how we can approach conventional problems with modern solutions. So what do I recommend? I like just to conclude by giving a list of things to do. Know your application, quantify what you're trying to capture, specify filter requirements, monitor air quality, observe the geographic location, avail filtration and ventilation rates and efficiencies that is fit for your buildings given the human occupancy. Utilize appropriate technologies so you don't over-design, but you also don't under-design your filtration selection. Employ a filtration plan. Most importantly, think of filtration as a system, not just as a filter you install in the HVAC system. Consider human occupancy, ventilation rates, and identify indoor air pollution sources just like we do in the outdoor. And if you're in doubt, always seek professional advice from certified filtration experts, and avoid dicey practices when it comes to maintenance, when it comes to any selections, whether it's HVAC equipment, heating, ventilation, air conditioning, filtration as well. And with that, I invite you to read some of my articles. I cover a lot of these topics in more detail. And at this point, I'd like to pass it back to Mr. Nabil.
Thank you, Dr. Iyad, for this very valuable presentation. It's very informative. For me, understanding the effects of pollutants on respiratory systems or lungs, and also cognitive performance, this really got me concerned. So I will definitely be taking the filtration prescription by talking to a filtration expert and maintaining good indoor air quality. Maybe spending, it's like you said, a little more money. And thank you for the book referral, Being Wrong. That I think would be a great read. With that, let's switch to our next speaker. Engineer Iyad Jurdi is a veteran in the HVAC industry. He's a seasoned director who is driven by his passion for sustainability and human well-being. He's also a martial artist, by the way. So throughout his lengthy career, Iyad has cultivated a reputation for leadership in HVAC building and sustainability and IEQ industries throughout North America and the MENA region. In his current role as a managing director of Bridgeshore Indoor Air Quality, Iyad is paving the way for sustainability throughout indoor air quality using non-chemical approach for cleaning and sanitizing HVAC systems. So Iyad is going to demonstrate to us a practical example of how keeping an indoor unit clean will help not only indoor air quality, but also performance in terms of efficiency and capacity of systems. With that, Iyad, please, the floor is yours. Thanks.
Thank you. Thank you, Nabil, for a great introduction, actually. And I also want to thank Dr. Iyad for a very informative session. You guys are going to see a lot of overlaps between what I'm going to be talking about. When it comes to air quality, when it comes to ventilation, there are a lot of really key points that standards everybody needs to be aware of. So such an introduction, we work with Petrichor, and we do work on raising awareness towards building sustainability through IAQ. IAQ, what we've seen in the market is something that a lot of people preach as a health-only related issue. It's has a lot of benefits, but it also plays a major role in sustainability, in green buildings, in energy efficiency. All of that is what we're going to be talking about today from a few of our field experiments and tests that were done earlier. So with that, we do deal with sustainable facility services and environmental solutions. And the name is our mission because petrichor as a word, it actually means a distinctive earth pleasant smell that frequently accompanies first rain. So I'm sure everybody's familiar with that. The first time it rains after a long summer, there's always this ground and soil smell. That smell is called petrichor. And that unique, crisp, clean smell is the same what we're trying to bring indoors and not only outdoors. And with that, every breath really counts for us. And why would I say that? It's pretty simple. Just a quick math here is going to show you that we look at the research and on a standard office building, we are seeing about 1 million bacteria per cubic meter. And that is an average amount of bacterial load in the air. That's as per Hewlett, one of their researchers. Now, if we're going to be inhaling 0.5 liter with every breath, and we do take about 15 per minute as human beings, so that leaves us with 500 microbes with each breath. Straightforward math. So every minute we are inhaling about 8,500 microbes. Leave us till the end of the day, it's 30 million breaths. Or I'm sorry, 30 million microbes throughout the breaths that we take throughout the day. So that gives you another insight at how important the air we breathe is, just as important as a healthy food we eat. It's as simple as that for us. So 13 million microbes every day. Now, thankfully, we have the systems built in us to really clean that and filter most of these microbes out. So we have our noses, nostrils, trachea, even in our lungs. It can capture and clean some of these microbes out. but majority of it really goes in. Now, what happens when we overload in these microbes or our immune system is deficient or not strong enough to really clean that out? Well, this is where you take a sick leave. This is where you go see a doctor. This is where you don't have the energy to do a lot of the activities that you are looking to do throughout the day. So it all relates. On the long term. We're also going to be discussing some of the disadvantages of low IAQ. So with that said, what exactly are we talking about? Like, what are the microbes? What are all these contaminants? Well, some are gaseous, some are particles, meaning actual microbes and viruses. So if you look at the right side of my slide, you're going to see a lot of gases, which is under VOCs, CO, random. We see dust particles, most of which are PM5, PM2.5, 1. And we have microbes and viruses. That's how the four main categories that I would like to segregate when it comes to contaminants in the air. And that is pretty much common because if we look at the EPA, we look at AHRI, we look at all the major, even UN, they all talk about the same thing, IAQ, the importance of IAQ. Everybody's advocating the same message, which is you're going to be spending 90% of your time indoors, whether at your home, whether at your office, at the mall, in your car. All these are air conditioning spaces, especially in the GCC region. There's really not a single time that you'd be sitting at home and the air conditioning is off. Summer, winter, doesn't really matter. So 90% of that, you're sitting and breathing the air that maybe in a lot of cases you shouldn't be breathing, right? So that's going to affect your health, it's going to affect your comfort, it's going to affect your well-being. And about 3 to 4 million people annually dies because of IAQ-related diseases. Actually, a couple of years ago, I read an article that in Britain, there was the first time ever that the cause of death on the death certificate itself was mentioned as IAQ issues, which is indoor air quality. That was a huge breakthrough to really put it on the death certificate. So low IAQ, now we know why it is, and that's going to be causing what we call a sick building syndrome. And that's a syndrome that we are seeing pretty much throughout. Reasons and causes for that, well, poor air quality, dust, VOCs, microbes, bacteria, viruses, you name it. Human traffic in and out. We have a lot of sandstorms that carry all these contaminants as well with them. Now, symptoms, some of which are physically related. So you get the dryness, the throat, you got a dry cough, sensitivity to odors, cold flu-like symptoms. But the two main things, and these are very, very important when you come to try to tangibilize or put in numbers the value of IAQ. It's in presentism and absentism. So it's about the sick leaves that the employees would take every year, a number of sick leaves. And it is about the actual productivity levels. And I'm sure everybody sitting behind the screen all day have had these few minutes throughout the day, or maybe longer, that you're just sitting there. You're there. You're looking at your screen, but that's it. Your mind is not here. Like you can't function. You cannot actually concentrate. And we're going to be talking more about that. But anyways, the smaller the particle, and this is very important, is the deeper that it would go. Remember we said about the natural filters that we have in our noses, but they can only capture 5 to 10 microns. The smaller it gets, 5 to 2 microns, these go all the way into our lungs, into our bronchi. And once they're there really isn't a like foolproof method to clean our lungs still today, right? So this is what's going to cause the long-term effects. And as Dr. Iyad also mentioned, with sick building syndromes, we're seeing verticals. Like it's not only, for example, high traffic buildings. We see it in residential flats where maybe a single dweller, and we see it in schools, we see it in hospitals, office buildings. So just to give you an idea of what we are seeing out there, we have 1/3 to 1/2 of all structures that have damp conditions. Damp meaning humidity through the air, and we do live in a very humid region or country for that matter. So that humidity is going to infiltrate, and once it does, it's going to create damp conditions, and that's going to create fungi, and it's going to create mold, which is pretty much poisonous for the human beings. We see it in schools a lot, obviously. And also, as Dr. Iyad mentioned, it's being proven right now. So we don't really have to expand upon that, that unfavorable learning environments for students would result from lower performance, lower effectiveness, lower mental capacities. So you're going to see less productivity from the students and from the teachers as well. So students are going to have less learning capabilities, and the teacher is going to be having less teaching capabilities because he doesn't have the motivation of the energy. Why? Because he's not getting enough oxygen, or she is not. Now, in hospitals, funny enough, there's as much as 5% of all patients developing nosocomial, which is infections not related. So you go for a visit, you walk out of the hospital sick. Whether you know it or not, that depends on your immune system. Now, office buildings as well, we're seeing obviously symptoms related to mucous membranes, skin irritation, breathing difficulties. Everybody related, or everybody in an office is going to be seeing a lot of these common features. All right, so now we know what we're dealing with. We know perhaps what to do about it from Dr. Iyad's presentation, but what exactly is it? So we need to dig deeper, especially that everything we're talking about is microscopic organisms. It's not like something except for dirt or dust that you can see with your naked eye. And I see that a lot in coils. People are going, coil is clean. Well, yeah, take a deeper look, do a swab test. Then I see the bacterial load in the coil. And that is mind-blowing most of the time. But anyway, we asked, okay, where are all these coming from? Like, I understand outside air, I understand poor filtration in the AHUs, but the majority of these need to be coming from within the facility. And we found the research that actually support that hypothesis. With Mendel, who came in and like, okay, let's look at bacteria and what do they actually need to flourish? They need two main things. They need dark environment and they need a humid environment. And if we look throughout any building, the only system that it actually exists with these, that satisfy these two conditions, is the fan coil itself. So the fan coil, the coil area, is the most humid. It's always humid and it's always dark in there. So this is perfect breeding ground for bacteria. And this is important to notice because a bacteria on a filter might not have favorable conditions to actually flourish and reproduce. And the duct as well, with all the duct cleaning that's happening, it's the same thing. There is no favorable conditions for them to flourish. But at the coil, perfect conditions. They have unlimited supply of nutrients coming through the air, being recycled. They have unlimited supply of humidity, and obviously it's very dark in there. So this is the actual main contaminant. And from there, with the air stream, some of these viruses, bacteria, the mold molecules will go with the air stream and will lay on the furniture, on the ground, through our breathing system, and will make us sick. So long story short, recommendations is periodically cleaning, non-chemical disinfection of the HVAC systems. And here I always stress on non-chemical, not only because of the business we're in, but mainly because if you're going to put chemicals on the coil, you're going to get all the TVOCs going all over the place. And then you're going to evacuate and pretty much shooting yourself in the foot because you're putting chemicals or acid damaging the coil just to kill a few bacteria, which doesn't really always work. So we took that to the test. So we took Mendel's research, we went to site, to the field. We're opening these fan coils. I'm like, okay, let's see what this guy is talking about. And these are actually the field findings that we have done. Here you're going to see some pre and post sanitization that we've done. But these are the coils. This is what a coil looks like. An average coil, I'm not putting the worst case scenario. An average coil, that's how it looks like. The closer you go in, the more you see the mold, the more you see the bacteria build up, the more you see these slime little things just growing up. Obviously, after cleanup, the coil should look like this. We took a look at the drain pan, and that's what came in. Now, rust is a kind of no surprise there. It's a drain pan at the end of the day. We don't always expect to have solid galvanized steel. But this is what we found. We found the actual mold growing up. If you notice here, let me just, we've seen the mold growing here. We've seen a lot of these bubbly, foamy water just sitting there. And the more we dig, the more we see. Why? Because drain pans are hard to get to, and they are really tough to, especially with chemical treatment or chemical cleaning or recoil. Everything is dropped in the drain pan. There's always this thin layer of water that's always going to be there, right? So if you're bringing all the bacteria and viruses and the contaminants from the coil into the drain pan, some of it will leave with the drain holes, contaminating everything in its way, and some of it will stay there. And then it's going to reproduce and retake the coil. Again, more drain pans, more issues. We took a look at the filters. We found the same thing. The blower motors, which are obviously, I would say 100% of the time, I've never seen somebody just sanitizing a blower motor because they don't have the actual means to do it. You can't drop chemicals on a blower motor. But everything inside that fan coil cabinet, we need to keep in mind that it is being contaminated. And for those who always want to see, because if you can't see it, it doesn't exist. Well, let's look again. We were fortunate to have a contamination tank in our devices, and this is actually the end result of the contaminants coming from any coil. And here we're talking about a 2 to 3 ton coil, a single fan coil. This is what comes out of it. A lot of people say, well, we do a chemical treatment for that or chemical cleaning. I understand, but most of the sites that they do it once a year, right? Which is pretty much, it should have been done 4 times a year or depending on the site function. But what I want to show here is actually for those who still doubt the air we breathe and how it looks like, and I can't see it, well, you cannot deny seeing this now. Now that you saw it, what happened to me? You cannot unsee it. It's there, and that's the air we're breathing. So the second part of the presentation, we're going to be talking about the current methodology that are being used, and from our experience in the field, what are the actual limitations that we're seeing, the feedback we're getting from different customers. So we have enhanced ventilation techniques, and that is a beautiful thing to bring in more outside air. Now, obviously, given that the outside air is cleaner than the inside, most of the time it will be. But again, with existing buildings, we would have a certain challenge, meaning if it's a new building, we can incorporate the new design for that. But existing building, if you want to bring more air, I'm not sure if the AHU can handle the extra load. And if it does, that's going to create additional power consumption. So if you have KPIs related to energy efficiency, that's going to throw you off chart, right? So a lot of things that you need to be aware of. Also, bringing air more fresh air that's not highly tempered, that's going to affect the HVAC load. So your HVAC system needs to be able to capture this extra load. And if it does, again, it's going to be ramping at higher load, consuming more power. So there's always kind of something that you need to really be aware of for existing buildings when it comes to dealing with more fresh air coming from outside. Now, we have the high efficiency filtration system, which is something that we also highly recommend for the AHUs. But unfortunately for existing and even new buildings, when it comes to the FCUs, then we're going to find certain limitations with the high efficiency filtration because most of the fan coils, they have these small ESP motors. They have a limitation on the amount of pressure drop through the coil plus the ducting. So they really don't have enough ESP to draw the air through high efficiency or HEPA filters. That's why most, if not all the fan coils, you see that mesh type filter, which is pretty much useless, or the washable type filter. And most of the time, as Dr. Yad also mentioned, they are deformed, they are not well maintained, and so on and so forth. Now, duct cleaning, UV lights, room air cleaners, all these new technologies we saw big bang after the pandemic. Now, when it comes to duct cleaning, and I'm sure you see all these kind of exaggerated pictures. The pictures that you see from our experience in the field, these are ducts that have been kind of left for 5, 6, 10 years before they can capture this much dirt. Don't forget, guys, duct is an uninterruptible open square. So with that said, air is going to be walking or going through the duct uninterrupted, except maybe for elbows or a few dampers here and there. So air doesn't really touch the duct. The majority of the air is going within with a few lining in between. And with the air moving, it doesn't really participate or doesn't the dust particles don't fall on the duct. So they're always on move. They fall on the ground, on the furniture, in the room, but not necessarily in the duct. So big marketing, obviously, after the pandemic with duct cleaning, how important it is, that is fine. UV lights is another, and I always use the example, if I'm going to go outside, I'm going to put UV protection. You go to the beach with your family, first thing you do is put sunscreen with UV protection. So with that said, I'm not sure if I want to put these inside the zone, right? Especially with not enough research or data so far to support or dismiss the cancer, skin cancer thing that can be caused by UV lights. Now, the two most common procedures you're going to find out there are chemical treatment and steam sanitization. Now, chemical treatment, you see it pretty much, it's the conventional way. It was the only way before we started talking about, hey, wait a minute, we can do it with steam, give you better results. But with chemical treatment, obviously, for those of you who haven't seen it, we have a small hand pump, and we literally spray chemicals, acid on the front of the coil. There's no penetration through the coil. It only cleans the surface. That is one. And so we don't have enough penetration, allergic reaction, respiratory irritations because of all the fumes coming out of the chemicals. You need to be careful about the exposure to carcinogens, potassium, sodium hydroxide, which most of these chemicals contain. And the coil coating itself will deteriorate, causing water retention and eventually would cause rusting of the fence. With steam sanitization, what we're noticing, it is by far from all these procedures, the most environmentally sustainable because you're using pretty much tap water and steam, nothing else. Less invasive, minimal downtime. We don't have dispersion. Some of the technologies out there would have also a dual flow, so steam injection and suction at the same time. So they would keep the whole area clean, no dispersion of material. This is highly important for data centers, high-end offices, houses, so on and so forth. De-icing and, of course, energy saving. Now, to top it off, what I would like to share with you is an eye-opener. It's a research done by PhD Hank in Harvard School. They looked at the actual payout or the salary. So they found out that, hey, you pay as a company about 10% on energy and rental and 90% on salaries. And everybody wants to save out of this 10%. But really, nobody looks here. Now, I'm not suggesting that we're going to be cutting somebody's salaries, not at all. But what I'm suggesting is increasing productivity. If you're paying this much money on salaries, then the least that you could pay or invest in is having high productivity, absenteeism, presenteeism. These are the two main things. So if we start looking at that, and they've done that, actually, what they have realized is that this is day one, which is conventional day at the office, nothing has been done. This is day one of a green building. This is after sanitization, and this is day two. And they started measuring all the cognitive functions for these employees. So what they measure is basic activity level, applied activity levels, focus, task finishing and orientation. How do you react to a crisis? How do you seek information? How do you use this information? Show analytical thinking. So all these cognitive functions, how do you put in a strategy? And what they have realized is that each and every one of those is significantly higher with clean air and better IAQ. And that's why we see a suggestion of shifting now into IEQ, which is indoor environmental quality. So not only the air, but the air has to be good, which is IAQ, but as well all the affecting factors around it. So you see here, we started not only measuring CO2, which is very common nowadays. I see CO2 sensors everywhere. And I always ask, well, what do you do about it? Like, we just note it down. But there are really no cleaning strategies for that. Now we talked about energy efficiency as well. And what I would like to note here is after cleaning the coil, you're going to notice a few things. One, the power consumption is going to drop. And these are our field readings. So we're going to see a drop in power consumption. We're going to see an increase in the airflow from, for example, 4.4 meters per second here to 6.5. And what's really important is the fin efficiency, which is the heat transfer efficiency. What you notice here is that this surface temperature was 18.3 Celsius, and it dropped down to 17.3 post sanitization and cleaning. So you're going to notice not only energy efficiency at the fan coil level, but you're also going to notice the energy efficiency and the power saving at the chiller level or the condensing unit level with all the indoor units connected to it. It all adds up because you're going to see an amazing increase in the surface temperature of the coil. Now we see that all over the place. So whenever we talk IAQ, it's not only about human well-being, it's about energy efficiency as well and environmental sustainability. Chemicals we're dropping on the coil is ending up in the soil, or it's not going anywhere else. And our lungs, obviously, but nowhere else. So for that, we're seeing power savings up to 7% on the fan coil level, the indoor unit level. So if you're looking at a chiller plant, you're going to see much bigger savings there after you sanitize the whole indoor units. We see it all over the place, some up to 17%, other up to 1 or 2%, depending how really dirty the coil is. Now, in terms of sanitization and the swab test that we're doing, what we're noticing here from swab test, microbiological sanitization, we do swab test on the coil and we measure it in the actual zone. So you notice about 100% efficiency, 99% efficiency, and when it comes to PM 0.5, 10, and CO2, PVOCs, everything is dropping in a great way. These findings, what I just presented, we really didn't rediscover the wheel here. This has been done by ASHRAE themselves like 20 years ago. And they've noticed the same things. They've done HVAC, AHU sanitization and cleaning. They found improving and savings in electric cost by $40,000 a year. Decrease in pressure drop, increasing cooling capacity by about 15%. Thermal efficiency, what we're talking about, the clean coil, clean fan by about 10%. Sensible thermal by 25%. We see latent by about 12% as well, which is very important for highly humid regions, just like Dubai. Obviously reduce fungal and bacterial load. This is as much as I want to share with you today. May have kind of took a few minutes more, but I hope it was worth it and was beneficial for you guys. Thank you for having me and for the time given. I'll give it back now to Nabil.
Thank you, Dr. Iyad, for another informative and interesting session. I was really surprised when you showed the real cases of buildup on, on actual coils, average coils. I would imagine if you have higher or bigger FPI, foot per inch, it would be much worse. So, which is, I think, explains the strange smell that I get when I turn my AC on in the room. So
now you know why.
Yeah, and so I understand now it's very important to keep your indoor coil clean to save on energy and also basically save your health and others' health. So with that, we have come to the end of our webinar. We have we'll have time to take just one question, I think. And we have one question from Dr. Farhan. He's asking basically, I'll address this question to Dr. Iyad. With the increasing emphasis on sustainable building practices, how are advancement in filtration media and technologies are addressing the challenges of capturing smaller particles like size 2.5 and 1 without significantly increasing the pressure drop and energy consumption in HVAC? Can you give or discuss innovative material or designs or give us, I guess, an example on that? Dr. Iyad?
Thank you, Mr. Nabil. I would give Engineer Farhan the award-winning question, certainly a very critical question. I would say there are at least 3 aspects to it. One is filter media. Filter media has advanced so much. Particle capture, if we're talking about particulates, particle capture efficiency has increased due to the nature of how filter media is manufactured. So filter media can have a much higher capture efficiency at a very low pressure drop, but also pleating machines have improved a lot, so you can also provide the pleating. 2, filter design. Filter design itself has improved so that you can provide a higher efficiency, not higher surface area necessarily, but higher efficiency, a lower pressure drop. And the third aspect I would like to bring in, which is more of something I'd like to see improved, limited space allocation for air filter installation in HVAC systems. We cannot do much with 1-inch filter and one-stage filtration in terms of efficiency. We cannot go far in terms of improving indoor air quality and providing cleaner air in terms of particulates. Now, let me add more complexity to this question. If we start to address beyond the particle capture, if I want to say I got gases and particulates that I would like to address, then things will get very interesting, a bit complicated, but still there are solutions. You can have sorbents introduced, whether as part of particulate filtration or at separate stages. And let me conclude with my final 2 points. One, we need to address the challenge of having filters being encapsulated in air handling units. That's very difficult because air handling unit manufacturers are possibly struggling to sell their equipment. So when you enhance air filtration in that limited space, it becomes a challenge. What do I suggest? I suggest an integration in performance, but in a way, a separation in physical systems, so that you have filtration as a system and not just as a filter. You install it in the system. That will give you a more space. So you have space allocated that you can have higher efficiency, but not just what we went through, which is the hype, going for HEPA filtration and increasing, or buying a bigger fan. We want to make sure that we have a very low velocity, very long, extensive or extended lifetime into the filters so that we can render the efficiency and the performance sustainable. Right now, what we have, very limited spaces, media that is either flat or pleated. We also need to ensure that the way we pleat filters and bring in surface area through pleating densities is optimized. I think this needs more work, needs more research. Increasing the surface area lowers the pressure drop, but it's not always the case. If you overdo it, you will start having the media resisting the flow rate with and without particulates. So to summarize, Engineer Farhan, filter media, filter design, space allocation for future air handling units.
All right, thank you very much. We have another question. We'll address this to Iyad Jordi. I guess this is talking about, indoor air quality is not going to be free. His question is, the air cleaner equipment's technology have improved. So why not considering having a complementary solution or built-in solution, I guess?
It is being put, actually. Like, it's amazing how many air cleaners I bump into in every office that I go to. But you need to keep in mind, I'm personally haven't looked deeper into the research. To me, ionization and zero ozone generation, these are mutually exclusive. So if you're going to have ionization, there's definitely going to be some ozone. I understand technology have improved, but something you need to keep an eye on. I'm glad he mentioned it. What you also need to keep about the room air cleaners, the performance and the size. So most of them would be undersized. Air cleaners in a room, I'm not sure if all the air coming from the fan coil. So if you want to look at this scenario, you get the fan coil with the coil with all the bacteria built up, and then it's being dumped into the room. Now, the air cleaner is not capturing all this air, so we are breathing most of this air before it actually goes through the air cleaning. So that makes it, as a complementary solution, I'm all for that. But always keep the coil clean. Electrostatic precipitation is something that is of concern. Ion generation, as we mentioned, it causes irritation for the lungs and throat. And most of the time for asthma, allergies, bacteria, unless it actually has a HEPA filter built in, you're really not gonna see much results coming out of
All right. The last question I will ask is on the ozone. Dr. Iyad, also Gerard, as an example of ionization is practically efficient, and now with zero ozone production, is that true? Are there zero ozone production ionizers or ionization filtration?
I'd rather not really comment on test reports which I haven't seen.
Okay.
I think what would be really good to kind of zoom out. I think we have a much more broader homework to do. Right now, we looked at what happened in the pandemic. We've tweaked every single standard, whether it's filtration and ventilation. I think the question we need to answer today, have we perfected ventilation rates, filtration efficiencies? Are buildings fit to occupy? Are they being rendered as safe place to work and live in? The second question is, we need to look at air monitoring systems, continuous air quality monitoring systems, because this is basically the exam HVAC equipment and filtration systems would have to pass to ensure that we have air quality that is fit for purpose.
All right. Okay, thank you both. I think this will wrap up our webinar for the day with no more questions. And please, if you joined late, we're going to be posting this recorded webinar on our YouTube channel so you can have access to it. We've exceeded a few minutes over the hour, so thank you for your time. Dr. Iyad and Iyad Jurdi, thanks a lot for joining us today. And if you guys feel free to contact us or contact the two gentlemen here for more questions or comments. Thank you very much. Have a good day. Bye.
Thank
Thank you
you.
for having us. Thank you.